Answer true or false for each of the following statements. If A and B are positive integers, then the greatest common factor of A and B and the least common multiple of A and B times the least common multiple of AB is A times B. Okay, let's look at a few examples and see if we can convince ourselves that this is true. So we'll do some easy numbers, like let's do the greatest common factor of, we'll have A be 12 and B be 6. Okay, so the greatest common factor is going to be 6. So the GCF of 12 and 6 is 6. And the least common multiple of 12 and 6 is 12. Okay, so does 6 times 12, A times B equal the GCF times the LCM? Well, yes, in this case, 12 times 6 equals 12 times 6. Okay, so that's one example where it works. But this one was a little funny because A and B turned out to be the GCF and the LCM. Let's do one that is where that's not the case. Okay, let's do an example where A is 12 and B is 16. So the GCF of 12 and 16, the greatest common factor for 12 and 16 is going to be 4. And the least common multiple of 12 and 16 is 48. So 12 times 4 is 48, 16 times 3 is 48. So that's my least common multiple. So is it true? Does 12 times 16 equal 4 times 48? It does. Yeah. They are both 192. So I'm pretty convinced that that this is going to be true. You could test a few more examples, um, but it turns out that that is always true. B, every rational number has a decimal representation that either stops, such as 3/4 equals 0.75, or repeats, such as 1/3, which is 0.333333 repeating. So every rational number has a decimal that stops or repeats. That is true. The sum of three consecutive numbers is always an even number. Ooh, let's test a few examples. Let's just pick some consecutive numbers like 3 plus 4 plus 5. So 3 plus 4 is 7. 7 plus 5 is 12. Okay, that works. It is even. Let's test another three consecutive numbers, like maybe 6 plus 7 plus 8. So 6 and 7 is 13. 13 plus 8 is 21. Not even. Okay, so this is not always an even number. It's false. If B is a multiple of A, then any multiple of A is also a multiple of B. I think it might be helpful if we pick some numbers for A and B that satisfy this if part, okay? If B is a multiple of A, so let's let B be like 40 and A be 8, okay? In this case, 40 is a multiple of 8 because 8 times 5 is 40. So B is a multiple of A. Okay, so any multiple of A is also a multiple of B. So if I have any multiple of A, it's also a multiple of B, is what this is claiming. So let's look at a multiple of A. So like 24 is a multiple of A. Is 24 a multiple of 40? That's no. 24 is not a multiple of 40. So we found a case where this is not true, so it is false. If B is a multiple of A and C is a multiple of B, then C is a multiple of A. Okay, let's see if we can come up with some numbers that satisfy B is a multiple of A and C is a multiple of B, and see if the conclusion has to be true. So B is a multiple of A. So let's choose A first. Okay, A is going to be 5. B is a multiple of A. So maybe B would be like 30. 6 times 5 is 30. And then C is a multiple of B. So C has to be 30 times something. So let's make C like 120. 30 times 4 is 120. So we've got an A, a B, and a C. So A is B is a multiple of A, C is a multiple of B. Is C a multiple of A? Is 120 a multiple of 5? And that is a yes, and that's always going to be true. Yes. And part F, if a number is not divisible by 5, then it is not divisible by 10. That's going to be true because if you make a prime factorization, um, if 5 isn't in there, then there's no way that 10 is going to be a factor. So this is true. Another way to think about this is to think about all the numbers that are divisible by 10. They always end in 0, and any number that ends in 0 is also divisible by 5, right? So if a number is not divisible by 5, then it's not divisible by 10 either.